Hi, good day. So let's have another example for the design of a base plate. So a base plate is to be designed for a W12 by 152 column, a 572 grade 50 steel that supports the loads a piece of D. Supposedly this is our dead load. A piece of D is equal to 890 kilonewtons and piece of L is equal to 2000 kilonewtons. So we are to use a 36 steel with Fy equal to 248 megapascals to cover the entire area of concrete. So if we say for the base plate to cover the entire area of the concrete pedestal, basically we have our A1 should be equal to our A2. So Fc prime is equal to 20.7 megapascals. Show complete solution for Lrfd. So let's have first the properties of our column. So to determine the minimum area number 1. So what is the properties of the W12 by 152? Okay, so from our database, so let's say Control F of the W12 by 152. Okay, so these are the properties of the W12 by 152. So let's have its base flange width and the depth of this wide flange in millimeters. Okay, so its depth is equal to its depth is equal to 348 and its flange width is 318. Okay, for the W12 by 152, okay, we have the flange width is equal to 318 millimeters, and we have its depth is equal to 348 mm. So these two values will give our minimum area 1, which is basically the width of the flange multiplied by the depth. So we have this is now area 1 is equal to 318 then multiplied by 348. So again, this is the minimum area 1. Okay, computing for that value, we have 318 then multiplied by 348. That is 110,664 square millimeters. So this is our minimum area 1. So for our next step is for the load combination. So we have that as the piece of U equal to the 1.2 of the dead load plus 1.6 of the given live load. So we have these values as 1.2 of 890 kilonewtons plus the 1.6 of 2000 kilonewtons. And this value is now equal to, we have 1.2 of 890 plus the 1.6 of 2000. That is, we have our piece of U is 4,268 kilonewtons. Okay, piece of U is 4,268 kilonewtons. Okay, so for our concrete, okay, the nominal capacity of concrete, or if we are to equate it to our ultimate load, so we have that as the value of a piece of U is with our reduction factor for the concrete, that is piece of C of the piece of P is equal to we have the reduction factor, then multiplied by 0.85 of FC prime multiplied by area 1, then the square root of area number 2 divided by area 1. But for this example, since we don't have yet the dimension of our concrete pedestal, and also according to the problem, we have the base plate is to cover the entire area of our concrete pedestal. That makes area 1 is equal to area 2. So which means basically if they are equal, area 2 divided by area 1, or the square root of area 2 over area 1 is basically equal to 1. So we can now compute for the value of area 1. Okay, so again, this value is simply equal to 1. So this is our piso view. Okay, the piso view is 4,268. That is in terms of kilonewtons. We are multiplying 1,000 newtons. Is equal to, again, for Lrfd, our reduction factor, the P sub C is equal to 0. It should be 0.65. So we have this 0.65, then multiplied by 0.85. The given FC prime is 20.7. Then multiplied by area 1, the square root of area 2 over area 1 is simply equal to 1 unit. Computing for the equivalent of area number 1. So we have that as 4,268 times 1,000 newtons, then to be divided by 0.65, to be multiplied by 0.85, then our FC prime is 20.7. That is 373,182.941. Or if we can have it in whole number, that is 182. So let's say 183 square millimeters. So this is our area 1 based on our ultimate load. So what is our minimum area 1? The minimum area 1 is 110,664. So this is greater than our minimum area 1, which is equal to 110, then 664. Okay, square millimeters. So which means this area is adequate. Okay, so we have now the value of area 1. So let's have the dimension of our base plate. So we have the dimension D, which is we are using here N, and the dimension B. So how do we compute for the dimension N? So we have our equation from the previous video. That is also N is equal to the square root of 1 plus delta. Wherein the value of delta is 0.5 of 0.95 of the D minus 0.8 of the B sub F, or the dimension of the wide flange. So again, how do we compute for the value of N? The value of N is the square root of area 1 plus the delta, and the value of delta is equal to 0.5 multiplied by 0.95 of the D minus 0.8 of the B sub F. Okay, so let's have the value of delta is the square root of, that is 0.5 of 0.95. What is the depth of this wide flange? Okay, that is 348. Okay, minus 0.8. This is 0.8 of 318. So the value of our delta is now equal to 0.95 of 348 minus 0.8 of 318. Okay, then multiplied by 0.5. Okay, the delta is equal to 38.1 millimeters. Okay, so we go back to our value of N. The value of N is equal to the square root of what is our computed area 1. That is 373,000. So 373,183 plus the value of delta. This is 38.1. Okay, the value of N is now equal to, okay, we have the square root of 373, 183. then plus the 38.1. So this is 648.99. 648.99. If we are to round this up to the nearest value, which is divisible by 5, for easier layout, we can have it as 650 millimeters. Okay, that's 650. So again, if we are to compute for the area 1, or the total area 1, ay 373. So what is the equivalent of area 1 to determine the value of B? So area 1 is equal to the B times N. So our area 1 is 373,183 is equal to the value of B. The value of N is equal to 650 mm. So we'll be having the value of the B for the dimension of our base plate. That is equal to 373,183. That is to be divided by 650. Okay, this is 574.128 or 113. 574.13. If we are to round this up to the nearest value divisible by 5, that will be 575 mm. So for our conclusion for the dimension of our base plate, excuse. Okay, this is N by B is equal to 650 by 575 millimeters. Okay, this will be our the dimension. So if we are now to compute for its thickness, okay, but before we compute for the required thickness of the plate, so let us check the bearing strength of our concrete. So the value of N is equal to 650 mm, and the value of B is equal to 575 millimeters. That will be the dimension of our base plate. So 650 by 575. So let us just check if our piece of that is a reduction factor, P sub C multiplied by P sub P, which is equal to the value of P, then multiplied by 0.85 of the FC prime, multiplied by area 1, and multiplied by the square root of area 2 over area 1. But again, this dimension is the same as 1, since we have area 1 is equal to area 2. And then let's have the actual area of our base plate using the actual dimensions. So our area 1 now is equal to, this is the N times B, equal to 650 millimeters, then multiplied by 575 mm. So that is 650 by 575. So 373,750. So 373,750 square millimeters. So we are using this actual area 1. So let's have a reduction factor. I would have the reduction factor P sub C multiplied by P sub P is equal to 0.65, then multiplied by 0.85. Our FC prime is 20.7. Then the actual area 1 is 373,750. Then again, so square root of area 2 over area 1 is 1. And this should be less than the value of the P sub U. So this value is now equal to, we have that as 0.65, then multiplied by 0.85, then 20.7, then 373,750. The resulting value is in newtons. So we are to divide this with 1,000 newtons. So we have that as 4,274.49. 4,274.49 kilo newtons. By the way, so this is just a correction. It should be greater than. The capacity of our actual area should be greater than the actual ultimate load. So what is our ultimate load a while ago? That is the same as, that value is the 4,268. So this is the capacity. The bearing strength capacity of our concrete is greater than the actual piece of view, equal to the 4,268 kilonewtons. So we can conclude that this dimension, the 650 by 575, is adequate. Okay, so other checking. So what if we have the other values of the checking? This term. The term that we have 0.8, that is the nominal strength of the concrete. 0.85 of FC prime, area 1, multiplied by the square root of area 2, divided by area 1 should be less than or equal to 1.7 of the FC prime times area 1. So if you are to check our reference, so that is 0.85 FC prime area 1 square root of 2 over area 1 is less than or equal to 1.7 of area 1. So let us just check. We have 0.85 of FC prime is 20.7. Our actual area 1 is 373,750. Then again, we have square root of area 2 over area 1 is simply 1 since they are equal. It should be less than or equal to 1.7 of 20.7, then multiplied by area 1, 373,750. We have that 0.85, then multiplied by 20.7, then area 1, 373,750. This is again in newtons, so divided by 1,000 is 6,576.13 kilonewtons. Is it less than or equal to this value? The 1.7 of 20.7, then multiplied by 373,750. Then divided by 1,000. So more really this way less than this value on the right. So 13,152.26. So this is this condition is satisfied. Okay, so we are now ready to compute for the required thickness. So we have our formula for required thickness. That is this L, the square root of 2 piece of U, 0.9 of Fy times Bn. So again, we are following the method of Lrfd. So we are to compute for the value of L. It is the largest of M, N, or the lambda sub n prime, or lambda sub n. This is the lambda sub n prime. In some references, this is basically the same as n prime. So how do we compute for M, N, and the lambda sub n? So if we are to check the equivalent of our n, what is the equivalent of n? On this figure, the equivalent of n is simply equal to the 0.95 of the d plus 2m. So if you are to compute for m, that is n, we transpose this term 0.95 of d, then divided by 2. Okay? So that's how we compute for the value of m. So computing for the value of m, that is equal to, the value of n is 650 mm. Minus 0.95 of d. A while ago, we have the value of b sub f is 318 and the value of d is 348. So multiplied by 300, 348, then divided by 2. So we'll be having the value of m. So from our figure, so these are the 2 m's. Okay, that is, we have 650 minus 0.95 of the d, 348, then to be divided by 2. Okay, we have that as 150. Okay, we have 159.7 millimeters. Okay, what about the dimension n? Okay, the small n. Okay, the small n, if you are to observe, what is the equivalent of b? The equivalent of b is equal to 0.8 of the b sub f plus 2n. So if you are to compute for the value of n, so that is the same as b, we transpose this term, 0.8 of the b sub f, then divided by 2. Okay, computing for the dimension n is b is 575, minus 0.8 of the b sub f, 318, then to be divided by 2. So we have the value of n is now equal to, that is 575 minus 0.8, 0.8 of 318, then divided by 2. Okay, 160.3. So 160.3, that means we are no longer using m since this is already longer. Then for the last value, it is formula base. The lambda sub n. So again, in reference, it is lambda sub n prime or simply n prime. So we have, this is the lambda sub n prime or simply n prime equal to the square root of the b sub f times d divided by 4. So we'll be having its equivalent. This is the square root of 318, then multiplied by 348 all over 4. So computing for that value, we have, this is the square root of 318, then 348 equals, then divided by 4. So it is only equal to 83.17. So obviously, the value of L is the largest of m, n, or the lambda sub n. So our longest or the largest value is, this time, we have n. Then we are now to use that n for the computation of the required depth. So the required thickness, sorry. Okay, for the required thickness, that is equal to L, then multiplied by the square root of 2 p sub u divided by 0.90 of f y, and then multiplied by the b times n. Okay, so we are just to substitute. The required thickness is L. What is our L? That is the longest of m and n lambda sub n. So that is 100. Okay, we have that as 160.3 millimeters. This is 160.3 mm. Then multiplied by the square root of 2 times our p sub u is 4,268 kilonewtons. We are multiplying 1,000 newtons. Then, to be divided by 0.9. What is our Fy from our given? The Fy is 248 megapascals. So to be multiplied by 248 megapascals, then B is 650, the N is 575. The dimension of our base plate, 650 by 575. Okay, we have now the thickness is now equal to, okay, this is 160.3, then the square root of, this is 2 times 4,268 kilonewtons, so multiplied by 1,000 to be in newtons, then divided by 0.9 of 248. Okay, the B is, supposedly the B is 575, then the N is 650, but okay, it will give the same value. That is 51.277. Okay, 51.277 millimeters. If we are to round this up, okay, to the nearest value divisible by 5, say 55 millimeters. Okay, so our base plate, okay, for our conclusion, okay, the dimension is, okay, for the dimension of our base plate, that is N times B times the thickness. Okay, so we are using 650 millimeters by 575 mm by 55 millimeters thick. So this is an A36 steel with Fy with an Fy equal to 248 megapascals. So this will be our the design of our base plate. Alright, so this is our solution for this example.